All right, let's talk about something that really separates the good code from the truly great code: design patterns. They can sometimes feel like the secret language that senior developers use, but they absolutely don't have to be. So today, we're going to pull back that curtain and demystify them once and for all.
So let me just ask you this. When you sit down to write some code, are you just following a recipe step by step? Or are you planning a birthday party? Now, I know that sounds like a weird question, but it gets right to the heart of what patterns are all about. And funnily enough, it's a realization that programmers have been having since way back in the 1950s.
And here is where that analogy just clicks. See, an algorithm, that's your recipe. It's a precise step-by-step guide to bake a cake. You follow it exactly, you get the same cake every single time. But a design pattern, well, that's like the idea of a birthday party. Every party's different, right? Different people, different location, different cake, but you always know it's a party. It has a familiar structure, a purpose you recognize instantly. Okay, so let's get the official definition on the table. A design pattern is a reusable, proven solution to a problem that just keeps popping up over and over again. And here's the crucial part. It is not a piece of code you can just copy-paste. Think of it more like a blueprint. It's a template for an elegant solution, a way to structure your code that has been tried and tested by thousands of developers before you.
And, this idea isn't new at all. It kind of started brewing back in the 50s as soon as programmers started solving the same problems again and again. But it really became official in 1994 when four authors, who are now legendary, they're called the Gang of Four, they published this book that cataloged 23 of the most common patterns. And just like that, developers had a shared vocabulary, a way to talk about high-level software design. Now, hearing 23 patterns might sound a little overwhelming, right? But here's the good news. They all fit neatly into just three core categories. And if you can understand these categories, you're well on your way to getting a handle on all of them. So here are the three big buckets. First, you've got creational patterns. These are all about how objects get created, their birth, essentially. Then you have structural patterns, which are about how different objects and classes get pieced together to build bigger, more complex structures. And finally, there's behavioral patterns. These focus on how all those objects talk to each other and divvy up responsibilities.
Okay, theory is great and all, but let's make this stuff real. We're going to dive in and look at one of the most useful, most common patterns from each of those three categories so you can see how they actually work in the wild. Let's start with a classic from the creational bucket, the singleton. The goal here sounds super simple, but it is incredibly powerful. The singleton's entire job is to make absolutely sure that for a specific class, there is one and only one instance of it in your entire application, ever. And the go-to analogy here, for a very good reason, is a central logging system. You need one and only one place where all your application's messages and errors go. Can you imagine the chaos if you had multiple loggers all trying to write to the same file at the same time? It would be a complete mess. Same thing for managing a database connection or your app's configuration settings. And you can just see the difference it makes, right? Without the singleton, you've got potential chaos. You have multiple objects stepping on each other's toes, causing conflicts. With the singleton, you get order, you get consistency, and you have a single, reliable point of control. It's all about bringing some sanity to your application's shared resources. Okay, next up, from our structural category, the facade pattern. The whole point of a facade is to take a really complex, messy system and hide it behind one simple, clean, easy-to-use interface. It is all about taming complexity. Think about the last time you bought something online and you clicked that big Buy Now button. Well, behind that one single click, a ton of stuff is happening. The system's talking to a payment processor, it's checking inventory, it's running a fraud check, it's calculating shipping. That button is a perfect real-world facade. It gives you one simple entry point to a whole bunch of complicated machinery. And look at the impact on the code. On the one hand, without a facade, your code is a tangled mess. You have to know how to talk to all these different systems directly. But with a facade, it's just one clean, simple function call. The facade does all the dirty work and coordination behind the scenes, which makes your own code way easier to read and maintain. And finally, let's grab one from the behavioral group, the strategy pattern. This one is all about one thing: flexibility. It lets you define a whole family of different algorithms or strategies, put each one into its own object, and then make them totally interchangeable. The commute to work is the absolute perfect example for this. Your goal is simple: get to the office. But how you do it, your strategy,
might change every day. Maybe today you drive, tomorrow you bike, next week you take the bus. The strategy pattern lets you swap out these different approaches at runtime without changing the core code that says, I need to get to work. Now, without this pattern, you know exactly what you'd have: a giant, monstrous if-else block that just grows and grows and becomes an absolute nightmare to maintain. But with the strategy pattern, each method of transportation is its own neat, tidy, self-contained object. You can add a new way to get to work, like a scooter, without ever touching the code for car, bike, or bus. It's just beautifully elegant.
So we've seen a few of the classics, but how does this all apply today? I mean, are developers actually sitting around writing these patterns from scratch all the time? Well, let's get that senior level perspective on this. Here's the truth. You are using design patterns constantly, even if you don't know it. Modern frameworks like React or Angular, they're built on these patterns. When you use middleware in a web framework, you're using the chain of responsibility pattern. The real skill for a modern developer isn't to memorize the Gang of Four book, it's to see a problem and have your brain go, oh, I know this shape, there's a pattern for that. And this all leads to a really important trade-off. There's what you might call vibe coding. Just getting something working, exploring an idea. It's fast, it's great for prototypes, but it's usually disposable. On the other side, you have pattern-driven development. It's structured, it's predictable, and it's how you build real systems that can scale and be maintained for years. You just have to know which game you're playing. But I have to give a word of warning. Patterns are tools, not a religion. A super common trap for developers who are just learning patterns is to see them as a golden hammer and try to use them for every single problem. This just leads to massively over-engineered code that's actually harder to understand than a simple if statement. It completely defeats the purpose. So at the end of the day, what really matters is this. True seniority isn't about being able to list all 23 patterns from memory. It's about developing an intuition, a taste for good software design. It's about recognizing the shape of a problem and knowing deep down when a pattern is the right tool for the job, and just as importantly, when it's not. And that really leaves us with the one big question you should always be asking yourself. Where is that line? At what point does a helpful pattern that's meant to add clarity cross over and become harmful over-engineering that just adds complexity? Finding that balance, well, that's the real art of great software design.